Today we'll be discussing something more interesting, and which includes structs, enums, and methods associated with structs. Okay, so these kinds of like data structures really help you to create your own kind of data structures. For example, a struct allows you to create anything, any data type of what you require. Now, this has a varied lot of application in different fields, including networking, low-level programming, IoT, everywhere. Because the first example that I would like to quote is the case of a TCP or an IP packet. So usually we represent the packet structure using a struct, and we define what are the data items that are required. Okay, and then that is how we create a packet. Now, if you see the data types that we discussed in the past two sessions were included integers, float, different other kinds of like string, character, etc. So what if you require to create a data type of your own requirement? Okay, so you can do that by using structs. Okay, so you can create a composite of different data types as a single data type that you want to use, and that would be the use case of struct. And we will also discuss enum and also the methods associated with struct. Okay, so the first point of discussion is structs. So what is struct? A struct is a structure, is a custom data type that lets you package together the name and multiple related values that make up a meaningful group. So it allows you to create a group of different data items of different data types. Okay. Now you can create an array of structs that allows you to have an array of data type that is a custom data type that you create. Okay, and struct would be associated with some methods. Now, this is where we talk about the object-oriented programming in Rust. So, some people might be knowing what is Java and what is object-oriented programming in C++, in Java, etc. So, in usually in C++, Java, or Python, first we create a class and then we define different items required, and then we write the required functions for that particular class. But in Rust, we do not have a concept of class. What we use is struct. A struct will be created. The data items are actually present in the struct, and you cannot add a method inside a struct. Okay. What we use is an IMPL keyword to create a set of methods that allows us to do the object-oriented programming in Rust. Okay. So we'll see on to these things in the demo session. I just want you to keep in touch and get to know what the idea is. So structs are really useful and it's really found in everywhere. So if you are going into any kind of work, obviously you will see a lot of structs in the code base. Yeah. So in general, we can say that a struct holds related data together as a single unit. Can be used for encapsulation. Okay. And in turn, the object-oriented program allows us to create abstraction. So one good idea of the simple example would be to create a struct of student. Now, what comes to your mind when you want to create the struct of student? So the basic things that comes to your mind would be, okay, for a student, we require his roll number, his name, his age, and sometimes his marks. Marks could be again be a struct, like it could contain the marks of each subject that he has scored the marks. So the particular data type of marks could again be divided into an array of structs. The first one be the subject and the marks scored on the particular subject, right? So that is possible by using only struct. Okay. Now, yeah, I'll show you some examples so that it would be clear. So first create a main function. And before creating a main function, usually when we define a struct, it is actually defined before the main function. Okay, so there is a hierarchy of writing things. First, you use the use commands or the require, whatever is required, then you can use the use command to bring those things into your current program. The second one would be the struct definition, etc. And then you can have the function definitions and etc. Okay, so for a struct, you will use the struct keyword followed by the name. Usually it should start with it should go with camel case, but yeah, it's better you start with the caps. Okay, and then you can give the different data entities that you require to be produced into that struct. So what comes to my mind when I think of a student would be name, which is a string, and then let's say we will have age, which is I32 because it's a number. And yeah, I don't want I32 because more peculiarly we can say it's U8 because age is always positive, right? So you don't want a negative value to be in there. It can be peculiar, you can be uh, like putting in bounds for these values so that it does not exceed a particular value or it does not go below a particular value. Okay. Now, what else? So let's say roll number, and that also can be created as U8. Okay. So this is how we define a struct. Okay, this is how we define a struct. So similar examples could be also seen here, where I have created a different struct like a user, and I am keeping different entities like active, which is the data type bool, and username. Now the thing that you need to recognize is this struct is a single entity which encapsulates or hold each and every data item. Okay. So now these things can be used as single. Now let us see how we can do that. So the basic approach would be to create a variable and then create the struct component. Okay, it should be like similar to object oriented program. If you are familiar with object oriented, and you can actually grasp it really fast. But if not, then just consider it as creating a variable. Okay, so let mute s is equal to student, and then we want different entities like name to be string from, like say, George, and then age to be 25, and roll number to be 170. Okay. So now what I did, I just created a variable which is actually a struct. Okay. So I have used the struct student in order to create an object of the student and then passed it to a variable s. Now I've defined it as mute so that I can edit its value at any point of time. Okay, but you cannot easily print this struct because if you directly use a println and then the struct is s. Okay, and let's try running this program so that you can have an idea. Session 3. Proceed practice. Oh wait, it's not session 3. Proceed. So this is how we used to compile the program. And yeah, so you can see an error, right? The student cannot be formatted using the normal formatted because it says a debug trait is not implemented for the struct student. Now this is the problem in the when initially we create something. What happens is we want to like see it in the terminal. So we want to print it. But usually things are not very easy to be printed in Rust. Usually we require a debug trait to be implemented for each and every struct in order to actually allow it to be displayed. So there is an easy way of doing these things, and the compiler gives you an idea what needs to be added in order to solve this problem. That is, add a hash derived debug. So let's copy it before the struct definition. So it's like, okay, you place it here. Hash derived debug. So what we are doing is we are deriving the debug trait. Okay, we will discuss about what is trait and all in later sessions. You don't have to worry about it. So momentarily, you just need to know that, okay, you require a hash derive of debug trait in order to actually print the contents of the struct student. Okay. Now let's execute this program again. Okay, first we will compile. And now you can see that, okay, there is one more error because I haven't added a semicolon at the end. Okay, now what is the problem? Okay, we do not have any problem right now. I think, yeah, it's working. Now let us go for practice. You can see, right? The struct is student name is George, age is 25, and roll number is 170. So you can see something similar to a JSON. Okay, something similar to a JSON, right? So if you have used JSON, then you might know, okay, this is similar to a JSON because we have each key and then corresponding value. Okay. So what we use is we encapsulate it into a particular struct. So we have a defined data type, and we have different entities defined for that particular data type. And then what we do is basically we will give some values to it. Now, once I set this as mute, that allows me to edit any of its variable, right? So let me see if I can do that. Println when it's require this. So I just see this, Control V, and let me do like s dot name equal to string from Helen. Okay, now let's try to execute. But what happens? Okay, it compiles successfully. Now let's execute. So initially you can see the struct student is George, and then I changed the name to Helen. Okay. So what happened? Initially I created, but this was a mutable string or mutable struct. So when you create a mutable object or a mutable struct, it allows you to edit each of its components. Okay. So here I can edit the name, the age, the roll number, anything as I required. Okay, so initially I created this thing and I used my debug operator to print the struct. Meanwhile, I was using the derived debug in order to print it into the screen. I think you got an idea of what is happening here. Okay, now, yeah, so I changed the value and then I printed it again into the screen. So you can see the change is evident. Okay, now that is the basic idea of like knowing what struct is and how to work with struct. But you'll have some good assignments regarding how to work with struct, and I just wanted to add something more, like the solutions given to the particular assignments for the previous sessions, they are not strict like it should be written in that particular way. It's actually just a model solution. So your solution will be of any form. If it allows you to have a particular input against a right output, then your program should be right. Okay, so it's just a format, doesn't mean that it needs to be in that format. Okay, now we'll have some interesting programs coming for struct 2. So this was the basic struct idea that you have. Okay, so we created a struct and then we changed its value and then we use it. Now you can create some other different kinds of struct. That is, the normal kind of struct when it comes to our mind is like this. Okay, it's an encapsulation of different data entities. But what if we can also have a struct like a tuple? So that is called as a tuple struct. Okay, so what is a tuple struct? Tuple struct is similar to, the definition is like this. You need to use a hash derived debug before every struct definition in order to print it. Okay, now you just create or you define struct and then write the name and then use a tuple to define the different kinds of data types and the number of entities required. So here I have not named any of my variables or data entity. Rather, I have specified the data type against each of the entity. So a struct color, which is actually a tuple struct, should contain 3 elements. Each of them should be of the data type I32. So it's similar to a normal tuple. Okay, but the idea is we require to use the struct so that we can identify them as different entities. Now this is very useful in case of color representations for image processing, where we usually represent a pixel using different intensity, a combination of RGB, where each value changes from 0 to 255. Okay, so in similar cases, we want a struct which is a standard representation or an encapsulation of the data items. I think the point is clear. Now we create a similar variable like this, like let black is equal to color 000. Now 000 usually represents the color black. If you're familiar with image processing, then you could get the topic. But if not, it's not a big problem because the minimum intensity is color. Okay, that's black. The minimum intensity color is black. So yeah, this is how we actually create a tuple struct. Okay, now you can use it to print as well. So that is the basic idea of knowing structs. Now there are many different applications of having structs, and this is how we create a struct. We will see how we can create methods to work on with structs as well. Now I need you to look into one more important thing in the case of struct. If you see that I have initially created a variable named user1 which contains these different entities. Okay, and then I have changed it value of the email from string to another email example. So this initial, like this one, the third entity would be changed to this value. Okay, similar to what we have done before. But then I can use this data, the data of user 1, in order to auto fill my data for the next variable. Okay, so let user 2 is equal to user, and then I want just only want to change the email of the user 2. Okay, then all other entities can be same as that of user 1. So you can use this representation to do so. Okay, this representation to use. So basically the idea would be, we will see in this case, to initially S1, okay, and let mute S2 is equal to student, okay, and I want my name to be different because each student will have a different name, and then struct name from Gregory, okay, and then I want everything that is similar to S1. So this is how we do it. Now basically this is similar to what we have done here. Okay. So the idea is I have created a second struct, which a second variable for the same struct with similar data except the name variable. So name is different from S1, but every other component or data will be the same as S1 in S2. Okay. I think the idea is clear. Now we will try printing the S2 is S2. Okay, printing that. There is no errors. There are only warnings, right? Yeah, we are good to go. Yeah, you can see struct S2. The name is Gregory, but every other component is auto-filled while I use this kind of a representation. That is a dot dot S1 means fill every other data which is actually present in S1 to the corresponding locations in S2. I think the idea is clear. It's pretty much simple and similar to what we have done before. Okay, either you can go for like simply writing, okay, I want to change the age which is similar to S1. So we can write S2 dot age is equal to S1 dot age. S1 dot, sorry, S2 dot roll number is equal to S1 dot roll number. So it's a similar way and a simple way to do this particular thing. Okay, I think that's clear. I'll go back to the PPT. So we talked about how to define it. We've also seen a particular example where we are creating a struct. So creating a struct is by using a keyword and then giving it a name. Make sure that it starts with a capital letter and you should follow the camel case as well. Now we have structs to use a struct. How to use a struct? We have also discussed that. How to create the variable, how to fill the data, and how to autofill from the data by using a previous variable that has been created, how to access data. Now to access data, you can use the dot operator. Okay, I think it is easy to understand. For accessing any of the data, what for example S2 dot name, you can use the dot in order to access the name from the a particular struct. So like say S2 student name is, so we can use S2 dot name. Okay, now there is no issue with the compilation. Let's execute. You can see a student name is Grigory. So you can use the dot operator to access each and every element which is actually present inside the encapsulation of the struct. I think the idea is clear. It's very simple. Yeah. Now we'll see simple quiz time so that we will check whether you got the idea of the structs. Okay. Think you have gone through everything. The basic idea was to create a mutable or immutable struct and to autofill from data to access it using the dot operator. Okay. I'll put the polls open. Yeah, today we have 5 polls. I'll on the first one. I think you can see the questions. Please try to answer them. The first question is untyped question: to access values from a struct, we use which notation? Option A is star, then we have hash, we have dollar, we have dot. Okay. The second question is state true or false. A struct name should be in camel case according to Rust conversion. Okay. The options are true and false. So guys, take your time. We'll be given a minute and 30 seconds to answer. So the first question was to access values from a struct. We use which notation? The correct answer is dot, as I have actually mentioned it just before. Okay. The next question was state true or false. A struct name should be in camel case. The answer is true. We also discussed that. Okay. I'll go back to the theory. So we have discussed how to fill the forms of data. So I think now it's very easy to understand. You can use another or previously created object to auto fill from the data in the second object. Simple. We also discussed about the tuple strikes, where you can use struct color or struct point. You can relate this to real world situations. So color is used for the image processing things, and for point is used to actually do a spatial notation of each and every point in the screen, or even in case of a mathematical representation, you can actually use the struct point and color. The point about this is if you are familiar with image processing, and with these two structs, that is a struct point and a struct color, along with a 2D array which contains these data, can represent an image, because we know each and every point that contains the different kind of color. So color could be represented using I32, and similarly struct point could be I32. Okay. And this is how we create an object that black is equal to color 000, that origin equal to point 000. So it's a tuple struct creation. In tuple structs, we do not specify the name of entities or data items. What we do is we just specify the data type and the number of data that needs to be placed into the struct. I think the idea is clear. Now you also have a different struct, that is a unit struct. This is not very important because usually you might not be using a unit struct because it usually comes with an IMPL trait. Now a struct with no fields is called as a unit struct. So it looks like this. You just type the struct keyword and place a name. Okay, and that's it. So you do not have a data or any kind of entity inside a unit like struct. It's just a struct keyword and then a name. So it can be useful when you need not implement a trait on some type, but do not have any data that you want to store in the type itself. Okay. So that is usually happening with unit-like structs, when you have to implement a trait on some type, but you do not have any data that you want to store in the type itself. So that is a unit-like struct. Do not have to think more about unit-like struct. So basically, you create a struct and then place a name. No data entity. That is the idea. Now, yeah, we have seen similar examples with you can create any kind of struct. This is another example, that is struct rectangle with two different things. So what comes to your mind when you think about a rectangle? You have a width and a height. What is the situation if you are using a circle? So in case of a circle, the thing that comes to my mind is radius, right? So that is the idea. Now you can use functions to work with these kinds of structs. So rather than passing just some values, we can pass the struct itself to a function so that it returns some value. Okay. Now this is what is going to happen. The idea will be to, like, see. I'll just show you an example. I think there I do not have an example here. Obviously you'll see. Okay, so yeah, I'm going to create a struct named a rectangle, and what are the two things that comes to my mind is width, which is u8 because it is always positive, and height, or like say length, which is also u8. Okay, and now I want to create a variable of that particular data type. So like say let r is equal to rectangle. Just want to make sure my typo errors are not happening always. Yeah, so width is like say we will give the value 4, And for length, I'll choose the value 5. Okay, now you want to find the area, right? So print ln the area of the rectangle is, and let's put this here, and yeah, so area of and rectangle. So let's say and r. So what am I doing? I am passing the reference to this struct into my function. Why am I not passing the entire struct into the function, and rather by using a reference? We have discussed much about these things in the previous session. I have already told you that when you pass something into a function, then you cannot get it back. Okay, so you need to pass a reference to the object into the function so that you can actually get it back into the main function. So the idea is to create an area function that actually takes, let's say, R, which is of the data type and rectangle. Okay. And it gives me an output that is U8 because it would be an area, right? So it takes width and it takes length, should multiply these things, and then it will return me an area. And area should be U8, or like we have given both as U8. So I think we would prefer a U32 because sometimes the size may overflow. Okay. Now what we need to return? So we need to return the r dot width, that is the entity, star r dot length, right? So that is what we need to return. And now we have defined the function, we have defined the struct, we have placed the derived debug trait, and we have created the variable for that particular struct, and we have a print message to show the area aspect. So I think we are good to go. Like, see if we have any errors. Okay, there is an error. What it says is convert a U8 into a U32. So expected U32, found U8. Okay, so the data type is not changing. So we will just place the U8 here, and let's see. Okay, now it runs well and we can execute. Yeah, so you can see the output as the area of the rectangle is 20. So what it does, it creates a struct. We are taking its individual entities, the width and the length, and we are multiplying them, and we are returning the area of the rectangle. I think the idea is clear. You can try out many examples as you want. Create the same for circle, or for some other kind of calculation for marks. You create marks, you define the average marks, like define the median of marks. Anything can be done by creating a function. Now we'll be discussing something more interesting: why creating these functions individually when you can actually link these functions with the struct themselves. So that is what we will see in the next session. So as you can see, I am passing the reference. Make sure you only pass the reference. If you pass by mistake, if you pass the entire struct, then you cannot get its components at a later period of time in the program. I think the idea is clear from the last session. Yeah. So that is all, I guess. So the instance is passed. This is important as we pass the reference. I have discussed that. Now the debug trait, we have also discussed about the debug trait. The debug trait needs to be derived because if you need to print some components of the struct, then the derived debug is must. Now you might have to sometimes require to use different kinds of trait, like the clone trait to take a clone of the particular kind of struct. Okay. So structs are pretty complex data structures because you can take it to any complexity as you require, because it's a custom data type. You can create any kind of data type using a struct. Now that is the idea. So you use a debug format specifier along with hash derived debug. Okay, I think you have seen these things in the example. Now I only wish to talk about the debug macro. So debug macro actually takes ownership of an expression, which is not opposed to println. So what is the difference? See, in println, even if you pass something into the println, it still can be accessed from the main function, right? It's not a problem. But debug macro is not like that. It actually takes the ownership of anything that is passed. So you need to only pass the reference while you are using the debug macro. So debug macro is similar to println. It is used to create an std output at different that generates a completely different std output. Okay, but the issue is it takes ownership of what is passed. So only you need to pass the reference. I think the idea is clear. Now it prints a file, the line number, and where the debug macro call occurs in your code along with the resultant value of the expression. Okay. And debug macro is used for debugging basically, so that you get a good idea of what is the error and where is the error occurring and many other data regarding the debug. Okay, most of you, if you are well good with programming, then you would know that there are different approaches for debugging. The first one would be using the println statement directly, and that is a crude way of doing it. Then you have the debug macro. This can be also used to debug, and then you can also use the VS Code debugger. It's already present in it. Okay, so there are different ways to debug, and DBG macro is one of the useful tools to do the same. But make sure you get the idea that it takes the ownership. So once you by mistake pass something into the debug, then you cannot get it back. Okay, so then you should have the idea of using the references. So let rect1 is equal to rectangle, and we use and rect1. Okay, so we are not going to pass the ownership, we are just passing the reference. Okay, so we don't want debug to take the ownership of rect1, so we use a reference to rect1. I think the idea is clear. Now I'll go to the second quiz of today's session. Yeah, I think you can see the questions. You'll be given 1 minute and 30 seconds to go through all the go through the questions and answer. So the first question is, which of the following is the debug format specifier? And I don't think I can say these options. So we have parenthesis, we have a colon inside a parenthesis, we have a question mark inside a parenthesis, a colon and question mark inside a parenthesis. Okay. And the next question would be state whether true or false. The DBG macro, the debug macro takes a reference of an expression. So the options are true and false. I think this should be easy. The first question was, which of the following is the debug format specifier? 58% got it right. That's the right answer using a colon, a question mark inside the parenthesis wrapper. The second question, most of you have got it wrong. The answer was false. The debug macro takes a reference of an expression. So the question was made a bit tricky, so that I think you need to think before answering the question. So the question was, the debug macro takes a reference of an expression. No, it does not take the reference of it. It takes the ownership of the expression. That is why we actually pass the reference into the debug macro. I think the idea is clear. Okay. So most of you got it wrong. 32% got it right. Good. Stop. Okay. I will continue with the step. So we'll talk about methods. Now, as you have seen, we have created a struct, and we know how to access its elements. We know how to manipulate its elements, update its elements, print the contents of the struct. We have also created different functions and tried to pass the object into the function. So why we cannot embed these functions, a standard set of functions for a particular struct along with it, so that it can be called easily? Okay. Now this is where we talk about the object-oriented program approach in Rust. That is, here, as you can see, I am going to put the area function inside an IMPL rectangle. Now what is IMPL? IMPL means implement the rectangle. So implement struct. Now this contains the methods that are relevant to the particular struct. Now you can take it as an example, like a rectangle would have different kinds of functions. The first one could be the area. The second one could be the perimeter. What about the third one? The third one could be the length of diagonal. You can have different entities and different functions defined for the particular struct rectangle. So rectangle will have a particular set of functions, right? Now let's imagine. So what if you require multiple area functions? So you require a function area to find the area of a rectangle, find the area of circle, find the area of a trapezium, or etc. etc. But you cannot give the same name to different functions, right? That would give an error. So same name to different functions is not possible. So what we come up with, is to create an IMPL that is specifically created for the particular struct. So the area function inside the IMPL of rectangle only finds the area for the rectangle. Okay, you can also create an IMPL function for circle as well. Now we'll see what happens in demo. So in the methods, see, I've created a struct rectangle width, height, and then I use the IMPL. Similar, like this function is just the same function that we have used in the previous session, but I just pushed it into an IMPL rectangle. Now, what is this IMPL rectangle? This actually defines the methods that are specifically created for this particular struct. Now, there is some differences in the parameters that you need to concentrate. Uh, for those who are literally new into object-oriented programming, make sure you get the ideas clear, and you need to try out more examples to get the idea of object-oriented programming into your mind. Okay, it's all about creating objects, some methods related to objects, and then using those methods to manipulate those objects so we can create abstraction and all these things. So yeah, for those who know it, it should be easy, but for those who don't know, try to cope up and try to understand. Okay, so we have used the and self here rather than the and rectangle. Why? Because as I mentioned before, the function is specifically created for the struct rectangle. So we are only defining those functions that are relevant to rectangle only. So the area should only call the and self, because the self here represents the struct rectangle. Okay, the struct rectangle is what the self means. The idea is clear, I guess so. So the self here means and rectangle. Okay. Now, why are we using the and? Because we are going to take an input as the reference. As I mentioned before, we do not pass the entire struct into the function. Why? Because then we cannot take it back, because we are passing the ownership. Now, we are not going to pass the ownership. Rather, we will pass the reference. So as you can see, this and rectangle is changed to and self, because self represents rectangle when you create an IMPL. Okay. Now, it's the same function. Now, let's see how you can. So, I've also created a struct circle, created an IMPL that is area for the circle using 3.14 into self dot radius into self dot radius pi r square, right? Now, I've created an object for the particular rectangle. So, it's a variable RECT1, which is equal to rectangle with 30, height 50. Println the area of the rectangle is RECT1 dot area. Now, this is something also more relevant. You can see RECT1 dot area. In the previous program, you can see I have passed area ampersand R. But right now, I created an object rectangle, and RECT1 was the name of the variable. I am using a direct function like dot area. Now, what does this dot area do? Now, it comes to the IMPL block. It searches for if there is a function named area. Then it checks for the parameters. The parameter is just and self. So it means take a reference of what is being added to the left of the function. The left of the function is the rectangle's object, right? So what it does is it takes the and rectangle as the parameter. Okay, I think the idea is clear. Basically, what we do is we can use a dot area function to call the area function that is specified inside the IMPL block, that is defined for the self, that is an the self here is rectangle. Now you see I have created a circles variable C1 which takes the radius 25.0, and then I am calling the C1 dot area. Now what if I did not use the IMPL? If I did not use the IMPL, then I cannot define two functions with the same name area taking different parameters. Okay. So now with IMPL, it is possible. And using IMPLs actually standardizes the way we create a certain number of functions for the particular struct, so that it is relevant to that struct. And this also makes sure that you are not going to pass any other kind of function into the struct, which is not relevant to it. Okay. So this means you can have every function that is relevant to a particular struct using the IMPL. Okay. I think the idea is clear. Now let's execute this program to see what happens. So CD session. I think taking the CD would be a hard task. You can see the output was the area of the rectangle is 1500 square pixels and the area of the circle is 1962.5. So what we did was we used an IMPL to define the function that is specific for the struct, and then we called it using this methodology, that is RACT1.area. So yeah, that is the idea of how to work with IMPL, how to work with object-oriented programming, and how to create and define structs and work with these kind of struct in Rust. It's similar. It's really similar to uh, Python, Java, etc. Even C++. You might have seen a lot in like self and how to use the self dot width, self dot height, etc. If you are familiar with a programming language already. If not, take your time and try working out more and more examples using struct. Do it for fun, so you'd obviously learn it in the long run. Okay. So yeah, that was all about the methods. So unlike functions, methods are defined with the context of the struct and a more trait. Now, what is methods? So methods are actually these functions that are defined inside the particular struct. Now we have discussed all these things. We should pass the and self inside the functions to describe the inside the IMPL block to access the fields. Methods can take ownership of self, borrow of self immutably as you have done here. So the methods, if you just pass normally self, it takes the ownership of the uh, object that is passed. If you pass and self, it is taking the reference. And now these self and self cannot be used to actually change the components. Okay. So you require an and mute self in order to change the value or update the value of the object that needs to be passed. Okay. So you can use different ideas in here to change and to access the values of different objects. So that's the idea. If you wanted to change the instance that we have called the method on as a part of what the method does, then we would use an and mute self as the first parameter. And mute self in order to change the components of the object. It's a similar approach, so I do not want to go and take the example because it will be like same. You can see it's a similar example. I think should be good. Can hold is not very relevant. Yeah, now we have methods with more parameters. So now we have like, okay, we have passed the and self only. So that means it takes that particular object of the struct that has been created. What if you want to add some more parameters? Okay, so there could be scenarios where you want to add some more parameters. Like say, if, okay, I'm going to do this for real fun. I'm not going to think. The basic idea is we will just add, like say, the number. Okay, say number is u8, and what I will do is now in the area you can use the number as 1. So this is my first rectangle, and I can say the number is okay. Now you cannot, okay, you cannot. So basically what I did was I just passed a number into this other. So what happens is the area function will initially take the and self component, that is the RECT1, and then it reads anything that has been input into the function. So now you have defined the number u8 here, right? You have defined the number u8. So what happens is this 1 is actually passed as a parameter against this number. Now you can use this number to do anything different with this. Okay. So I'm going to just multiply the number along with the value. And I'm going to return the product of self.width.self.height.number. Now what I will get? So I will not get the right rectangle area, but I would get the area multiplied by 1. Now this is not an issue because you would get the right answer again. What if we will just change it to 5? So if I change it to 5, the area of the rectangle, if let's say it's 10, then the answer that would be returned would be 10 times 5, right? I think the idea is clear. I just wanted to show how we can add additional parameters to a particular method that has been defined into a particular struct. So we use 5 and we access 5 here and we use 5 to return the area. And let's see what happens. So you know the previous values, right? It was 1500 square pixels. And now let's see what happens after the compilation. Okay, there is an error. What is the error? Okay, it says cannot multiply U32 by U8. The number expected U32 found U8. Okay, so it needs to be U32. Okay, got it. Now let's run. Okay. So it's 7500. So before it was 1500, right? So we have multiplied the additional parameter that needs to be passed into the function. So that is how you can add any number of parameters into the method that needs to be defined. Okay. This is how you do it. Initially, you will pass the answer to take the object itself, and then you can use any number of parameters to take additional components and do anything that you require. That's the idea. Then you are clear with the methods with more number of parameters. We'll go to the third quiz regarding the methods. I think you got a good idea of methods. Now we'll see how much you understand the topic. I've started the quiz. You'll be given 1 minute and 30 seconds to answer the questions. I'll read out the questions for easiness. So the first question is state true or false. After object instantiation, we can call methods defined in the struct using the dot operator from the object. True and false were the options. The second question is state true or false. Methods can't take ownership of self, borrow self immutably, or borrow self mutably. So yeah, the first question was after object instantiation, we can call methods defined in the struct using the dot operator from the object. The right answer is true. 86% got it right. Good. The next question was methods can take ownership of self, borrow self immutably, or borrow self mutably. The answer is 58% got it right. The answer is false because methods can take ownership of anything that needs to be passed into the string as a parameter. Okay. I'll stop the sharing. I'll go with the continue. Yeah. Next thing that you would like to discuss is the enum. Okay, what is enum? So now you've seen struct. So the difference between an enum and a struct is basically enum allows you to define a type by enumerating its possible variants. Okay, so you can have different variants for a particular value, and this can be actually shown using an enum. Basically, like you can imagine it similar to the IP address version. So you might have heard IP address has got two different kinds of version 4 and version 6. In IPv4, we have a different set for the IP address, and in IPv6, we have a different set for the IP version 6. So in order to define something that are actually like it is a list of different data types or a list of different types that you need to specify inside a particular abstraction or an entity, then we use an enum. Okay. So enums give you a way of saying a value is one of a possible set of values. So this is not like creating a struct. In a struct, we know, okay, we have to encapsulate these much number of data items of these kind of data types into the particular struct. But in enum, we actually show the different possible set of values that we can give for the particular enum. Okay. For example, we might want to say that rectangle is one of the set of possible shapes. So if you create an enum shape, then you can have different a set of values that could include a struct rectangle, a struct circle, a struct trapezium, anything. Okay. So if you create an enum shape, then you can hold different structs inside the enum as well. Now to do this, Rust allows you to encode these possibilities as an enum. So enums are very useful when it comes to the different set of possible values for a particular entity. Now this also comes under the part of object-oriented programming in Rust. Okay. So yeah, this was the example that I was talking about. Enums IP adder kind, you can use v4 and v6. Okay. So if you now how to access this? Okay. How to access a particular enums value. So when you create a variable, let 4 is equal to IP adder kind, and then you need to use colon and then v4. Okay, colon and then v4 needs to be used in order to access v4 from the enum. Okay. think the idea is clear. Now we'll see a simple example. Enums. Yeah. So here we have created an enum IP adder kind with v4 and v6, and we have created the struct IP adder which contains two things: the IP adder kind and the string. Okay. So my struct will contain the first thing as the IP adder kind and then the IP address. So we need to know first what is the type. That is, if it's a version 4 or a version 6. And then we need to know what is the address. Okay. So here that is why we create a struct like this, IP adder and kind and address in this one. And for the IP adder kind, we have two different choices, v4 and v6. Now let's create a variable and see how this thing works. Let home is equal to IP adder, kind is equal to IP adder kind v4. This is how you access the enums value by using two columns. Okay. And then address is placed against string from 127.0.0. So now we have the version, we have the address, and we have another example here, loop back, which is equal to IP adder, and kind is v6, and we are using the string from this one. Okay, so there are some options that you are actually seeing for the normal enums. So we work with enums. Okay, we can create it like this. Simple. What we do is we create the different kinds of variants and put it in an enum, and then we can use it in different scenarios as required. So this enum can contain any different kinds of data type as well. You can use a struct, you can use a string, you can use any different kinds of enum variants inside the enum. Okay, I think the idea is clear. I'll continue with the important part of enum, that is the option type. And yeah, we have discussed about this. We can use this method to call the value from this one. Okay, and this is a similar representation where you are calling v4 and then you are putting a string inside. Now, similar to tuple, where you can pass a value or that is a string into the version 4 and version 6. Now what we did, see, before in the previous example we created a struct with the version and the address. Now we have actually encapsulated that also into the enum. Okay, this is optimization. Now what we do is we have an enum with version as the initial component, and then we will have the string, which is the parameter that is passed into the version. So now with the single enum IP adder, we actually have both the information, whether it is a version and its string. So we know whether it is version 4 or version 6, and we will also have the IP address along with it. Okay, so this is how we actually use enums to describe different data types in a single enum definition. I think the idea is clear. So we use IP adder v4, a function call that takes the string argument and then returns an instance of the IP adder type. Okay, you do not have to confuse it with the structs. Enums allow you to have different variants of a particular type, and you can also pass different kinds of parameters into the each variant, so that this enum can be used to describe what is happening with the particular data structure that you are creating. So you can also do similar to this. You can have multiple U8s. You can have a string. You can pass any number of required variables into the enums variant. Okay, now we have discussed about enums. I think you got an idea. It is not much very complex. It is to see the different values or variations. Anyway, I will just show one more example. Like you can have the different variation. Like say I just want to pass a string for v4, and I want to pass u8, 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 and then u8 for v6. Okay, so for v4 I can have a string, and v6 I will have this one. I don't want this anymore, so just stop this, and we'll have the IP adder kind. So we don't want this as well, and let's create a similar thing, like let home is equal to what is present. We have the IP adder kind, or we can change its name to IP adder because that is containing everything that is required, and we have what version. So initially we will have the version 4, and you can give the string directly. So you can take the string value and you can pass it to here. Okay, so this is how you work with a string. In a similar way, you can change the loop back address to rather than giving a string, you can give the set of numbers, so 6-digit numbers. Okay, that is all about enums. Okay, I think the idea is clear. Which of the following should we use when we have more than one variant for the same variable? Okay, the options are struct and enum. Now we have the second question, state true or false. We can create an instance of an enum with any of its variants. True, option number 1. Option number 2 is false. The first question was, which of the following should we use when we have more than one variant for the same variable? The answer is enum. That's right. 76 got it right. And the next question was, we can create an instance of an enum with any of its variants. The answer is true. 86% got it right. Nice. Okay. Now we will go something more important. That is the option enum. Okay. Now this is one of the most important implementations of enum in Rust. That is to use the option data type. Now, before talking about the option data type, I need to talk about the null pointers and usually what happens when you return nothing. So there could be some situations where you have to return nothing, or you do not have anything, any normal value to be returned. Okay. So that in such kind of cases, what we do is we return null in the case of C++. Okay, we try to return null. Now, this usually creates another set of results and allows the program to panic. Now, how do you handle these kind of scenarios? So, Rust usually came up with a different approach, that is to use an option enum. Now, what option enum does is you can set the return type of a particular function to an option type so that it either returns a result, either returns a valid result or a none value. So if it returns a result, then it is usually encapsulated in the variant sum, that is SOM is sum of t, which where the t is the value, and what will you get is you will get the sum of t as your output. And if you do not have anything to return, then you will return the none. The use case of this is so that you can write handling cases only for sum so that you can get the values for sum, and you can also write cases for none so that you do not want to panic the program during execution. Okay, so different cases can be considered using the option enum in order to prevent errors. So how will you do it? An option type encodes the very common scenario that could be something or there couldn't be anything. Okay, the example is, if you request the first item in an empty list, you would get nothing. Why? Because the first element in an empty list is actually not yet created, and you're trying to access an element which is actually not defined. So this would return none. So in Rust, we do not have null, we only have none. Okay. Rust does not have the null feature, rather it has got none here. Now none is actually a variant of the option enumeration. Okay. So the enum option usually contains two things, the none and some t. Now you do not have to define the option enum because it's already present in the Rust library. Mainly contains two things. Sum of t means you have a value and the value is encapsulated inside the sum. None means you do not have anything to return. Okay. So this is the idea. Let some number is equal to sum 5 means the sum number is the type is option I32, and the sum number is actually not containing the value 5, it is containing sum 5, that is different from 5. Okay. Now let sum char sum e is contain sum which is option character. Okay. So the data type is really important. Now let's see what happens. We will try to see the example here. What if I just take this one and start a new program, then main Control V, Control Z. Let value is equal to sum 5. Okay, I'm trying to print ln value is value. Okay, let's see what happens. So when we try to compile, it says it is an option integer and cannot be formatted with the default formatter. So you might see that I cannot try to print it. Why? Because it is not of the type integer, it is of the type option integer. So you need to consider different things before printing an option integer. What it asks me is to try using the debug operator. We'll see what happens. Yeah, now it works, right? And I will try to print the output. See, the value is sum 5 and it is not 5. Okay, sum 5. So sum is an encapsulation for the value 5. So for a particular type option enum, you do not return the right value, but rather you would return the sum 5 if you have a value. If you do not have a value, then you will return none. Okay, I think the idea is clear. That is why I've actually shown it in here. So yeah, you will get sum 5 and not 5. Now we'll see how we'll work with this. So this is another example, that is to use the match keyword. What is match keyword? So match keyword is similar approach to what is the switch keyword in C or C++, and multiple if else in case of Python. So what here we will basically see it as an variant to the switch keyword in C and C++. So match does is match tries to match different cases against its corresponding output. So in an example, you see I have created an enum coin of different variations, like it could be a penny, it could be a nickel, it could be a dime, it could be quarter. So there are different variations of coin. Okay. Now I have created a function which converts a value in cents. So it takes the value, takes a particular enumeration or a variant of the coin, and it returns its the corresponding value in cents. Okay. Now it takes an enum as the corresponding parameter and it tries to return U8. You see, match coin, that means take this particular enumeration and match it. If the corresponding variant chosen is a penny, then return 1. The variant chosen is nickel, then return 5. It is a dime, then return 10. It's a quarter, then return 25. Okay. Okay. So it is going to match the particular kind of enum against each of its variants. Okay. So in L, every variant should be placed against a particular value in while using a match keyword. As you can see, what I have done is similar approach is been taken. Okay, we'll see what happens with the match. Yeah, I think I will just take this to here so you can have a better understanding. Yeah. Now, I want you to look at here. That is, first I am creating a variable let 5 is equal to sum 5. Okay. And then I'm going to say let 6 is equal to plus 1 of 5. So I'm calling a function and I'm passing this value sum 5 into the function. Okay. Now let's go to the function body. The function body actually takes an option I32. Now this is how you represent the data type while you are using a sum or a none. Okay. So you want an option I32. Now option actually represents the sum and none different kinds of enum, and the I32 that actually represents the data type that you're passing into the sum. Okay. So yeah, so what the function expects is a type option I32. I32 means the value will be in the I32 format and it is an enum operation option. And what it returns is I32. Now, if match X none, that means you need to return -1, else you need to return I plus 1. So for sum of I, it needs to return I plus 1. So I'll just show you, I'll just type it again. Match X. So you're going to match the value of X. And what are you going to do? If there is some value, let's say sum I, then you can return I plus 1. That is what plus 1 does, right? Now, if it is a none, then you can just return -1. Okay. So that is the idea. Now, what happens is here it is trying to print the value of 6, and you do not have to look at this. Okay, if you pass this one, then you would get a different answer. Okay, I'll show how it works. So initially we will try executing this program. Say practice. Okay, there is no error. Now we will execute. Yeah, now you can see the output is 6, right? So I have passed 5. It matched the sum and it returned 5 plus 1, that is 6. And what if I was actually going to pass the none rather than the value 5? So if I am going to take none here, okay, now what happens? No error. You can see I got -1. So against the data type that you specify, whether if it is none or it is sum, we have already written the instructions what needs to be done if it is matched against the LHS. So for a particular LHS, you can have a corresponding RHS that is specified using the match keyword. Okay, so that is what we use option for, and how to get the value from the option basically by using the match keyword. Okay. Think the idea is clear. So you can differentially take the two cases, that is the sum and the none, by using a match keyword. Yeah, this is the same yeah. And I want you to notice something else, that is matches are exhaustive. That is, we need to match for all possible fields the enum has. So when you are trying, or when you are going to use a match operator, or when you're going to use a match keyword, make sure that you have written cases for each and every considerate option. Okay. So usually in an enum, like option, you only have two things to be considered, that is the sum and none. But there could be different kinds of enum. Like initially I showed you an example of coins. I think we can go back. Here you see I have 4 different variants. So while I use a match, I need to type in each and every variant's corresponding value. Okay, that is very important, because if you try to access something that is already not matched or not defined, then it would obviously return in a panic. So we do not want the program to panic, and that is why each of its variant will be assigned a particular match value. So usually we are not interested, we might not be interested in writing values for every corresponding variant, right? So we only want to consider like defining the values for the 2 or 3 particular variants. Then we can use the underscore to have a default case for every other variant that is not described in the match till now. For example, when z is equal to 5, I am matching z against its value with the, if the z is 1, then it will print number is 1. And if it is 2, it will print the number is 2. And if it is any other value other than 1 and 2, it will just print the number is greater than 2. I'll show that example so that it will be more clear. So what we're trying to do is, let z or let x is equal to a number, like say 10, and I'm going to write match x 1. So if it is 1, then println x is 1. If it is 2, x is 2. Now in any other case, I just want to println some other number. Okay. Now we'll see what happens while I execute the program. You can see some other number, right? So that is what happens. It tries to match it with 1. The value is not right, then it tries to match it with 2. If it is also not coming to have the value 2 as its enumerated value, then obviously it will go for the last option, that is for any other case that is yet not defined in the match. So this is a general or default case that you need to consider while defining a match for any kind of value. Now this is must when you are actually working with integers, because usually what happens is you cannot write the different cases for every integer range value. If you use I32, then you need to define it for every value in the range, which is not possible, right? So what you use is use the default case, and that is the underscore. I think the idea is clear. If let is similar implementation, not very important. So if let syntax allows you to combine if and let into a less verbose way to handle values that match one value. So what happens is, can use if let sum max equal to configure max println the maximum. So what you're trying to do is you're trying to pass this value, right? The configure max, which is wait a second. So this configure max is actually sum of U8. And what we are trying to do is, if let sum of max, which is equal to the configure max of println the value. So we are trying to pass the corresponding this variable's inner component to be a println. Okay. And then you are going to pass the value. So if you do not want to include this, then if let enables us to only match what is required and leave others. So this is a particular case that allows you to only type or only specify the case for some of them required only. So you do not want to use the underscore, but it would be much better to use the match keyword, where you can actually consider the 1, 2 and all other cases by using a default keyword rather than if let. Okay. So this is one other option that you can use. So it was discussed. That is the main idea is to use match. Okay. Always use match to consider all the different possible outcomes for a particular kind of value that you're trying to match with. Now it's, I think, the time for the last quiz. I'm going to open the quiz for the match. So the first question is, state whether true or false Rust has a null feature. Second question is, state true or false enums are non-exhaustive. Okay, you'll be given 1 minute and 30 seconds to answer. Please take your time to answer it right. I think the time's up, so I'm going to end the board and I'm sharing the results with you. So the first question was, state whether true or false Rust has a null feature. And yeah, the answer is false. 64% got it right. Rust does not have null, it has none. And the second question was, state true or false enums are non-exhaustive. So the answer is false. I have already mentioned that enums are exhaustive. Exhaustive means you need to consider each and every case possible for the particular value. So the statement was enums are non-exhaustive. So basically it is exhaustive. So the answer should be false. Okay. I'm going to stop sharing the results. I think that's it. That's it for today's session. We have discussed about struct, the methods against a particular struct, the enums, and how to use the match in order to match the different case scenarios for a particular enum value. And we have also discussed about the sum and none, which allows us to take the different cases in if the function returns a null or the function returns a required value. It is a accepted value or a none. So these things can be considered by using option in. So that's what we have discussed for today. And I think Debug, is there anything that you want to add before we go to the Q&A? So guys, one of the questions that most people I think asked was to regarding how to take the user input. Okay, see why didn't discuss that till now, because it is not very important for us to discuss in the topics. But yeah, when you are trying programs, you might want to take the direct input from a user. Okay, in Rust it is a bit hard to take the values because initially you need to take the value as a string, and then I think the screen is visible, right?
Yes, Rishan, yes.
Okay, okay, great. Thank you. So yeah, so initially, in order to take a number, first we will just print, okay, ask the user to request the user to take a or give us a number. Okay, so print and enter a number. And then you want to create a new string because any input in Rust can be initially only taken as a string. So mute line. So we create a variable, let mute line equal to string new. So we create a new string. And then we need to call the IOSTDIN. Now this is the STD input standard function. Okay, that is very important for us, and we also require. I think we don't require that. Okay, so we require the IO, that is input output standard input function, to read the value, that is to read the string, and use this method, that is and mute line with a dot expect, that is error in reading input. Now this is a bit hard to understand because this is how Rust actually takes the string input from the terminal. So I cannot explain much about how what these functions are doing. The basic idea is you need to call the stdin function from the IO library, and then use a read line and pass the variable as an and mute reference into the read line function, also considering the possibility of an error using the dot expect. So dot expect actually handles if there is like you did not get a right value, or you didn't get a value against the request that has been placed. Now this is how you actually get a string input from the user. You might sometimes want to get the numerical input, right? Or any kind of float input. Now, what we do is we will pass the string into the required data type. That is, here I am trying to convert the string to U32 data type. That is, let n is equal to U32. So the data type is specified, and I'm going to pass the string variable. That is the data type against string new. So it is line. Line is what my new string is. And now I will use the trim. Trim function is used to remove the white spaces before or after the string that has been taken from the user. Now I will use the pass function. What does the pass function do? It will try to convert the string to the data type that is required or specified against its variable. So here we are using the variable n, and the data type for n is U32. So what it tries to do is it takes the line which is a string and pass it into the data type U32. Okay, and here also it tries to be safe. What it tries to do is it uses a dot expect, so that in case of any error during passing, it will generate this error message. Now it will have println you have entered the number. We will see the execution. Rust practice.rs. Here it shows the error use of IO module. Okay, so what we need to use? We need to use std IO. Now this is the library that you require in order to actually call the function. Oh, sorry, I forgot to add the semicolon. We execute, they ask for a number. Okay, let me say 5. So you have entered the number 5. So that is how you take input from the user. Basically, you take a string by using this format. Now, this is something that you need to mug up or sometimes even by heart in order to take input from user. Okay, there isn't much thing to understand. What you do is basically like this. And then you need to pass it into an integer or F64, then basically create a corresponding variable regarding the data type where you want to convert it to or pass it into, and then use this methodology in order to pass it. I think it is clear right now. Okay. With that, I think we can conclude today's session. Thanks, Deepak.